Good evening, everybody. My name is Anna Inario, and I'm part of the team here at PARC that puts on the PARC Forum, so thanks for coming tonight. We are super excited to have here Kathy, the Vice President of Operations from Arduino. She's been actively pursuing business partnerships for Arduino, and she also collaborates with the open source software community, and we're very excited to have her. In the past, she's been in the senior positions at Qualcomm Atheros as well, and she hails from Stanford as well as University of Minnesota. And on the side, she told me one of her hobbies is adventure racing, but I'll let her tell you a little bit more about that. So please help me welcome Kathy Giori.
Thank you. Okay, I'll just get this slide playing here. So hi, as Anna, thanks Anna. My name is Kathy Giori. I'm the VP of Operations at Arduino. And really my role includes, partnerships, business development, a little overseeing of marketing, PR, and something I really enjoy, which is product management. And my passion for products is what makes me think a lot about what path an engineer takes when they're prototyping something for the Internet of Things, and what it takes to build that prototype and what it takes to take it to market. And is that path, is it rocky? Is there something we can do to smooth it, to make it faster for people to take those products to market? Because there's a lot of innovation going on out there. So let me just start out and say, this is my short agenda here. Since Arduino is based on open source software and hardware, it's naturally taken like a center stage as the things portion of the Internet of Things. And but just being open technology doesn't really guarantee you success in the world. You have to be in a collaborative position with the community. You have to kind of put the broader vision and the goals of the project ahead of your own corporate business motives, if you will. And so that's why open source projects that sometimes are seeded by big industry don't necessarily succeed. They can fail, because as soon as you stop putting the resources in and you drop it, there's no community behind it, it will fail. And and I'll mention a little bit about why, the founding of Arduino, I think, was successful in that light. Also, because I work for Arduino, I wanted to mention something that maybe you'll have questions on later. I can talk to you, but we actually suffered a little bit in the last couple of years from a community standpoint, because some of the co-founders were going through a trademark war. That's fortunately, the two have become one, and we've resolved those legal issues. And the good news is that then in 2017, we're starting the Arduino Foundation. And the foundation will yet again improve our communications with the broader ecosystem. And one of the big goals of the Arduino Foundation is improving the software. The software is revolutionary in terms of its API, but now we want to improve the experience, make it even easier for younger kids and more advanced for the engineers and the entrepreneurs who are taking Arduino as a prototyping and then making Internet of Things projects out of it, and making that path to those production systems easier. And then another goal is improving the quantity and the quality of the educational curriculum around IoT. So now let's, I wanted to actually click on this so you could see it's just a demo that we're showing off at Maker Faire New York and Maker Faire Rome. And believe it or not, there are no smartphones used in this demo. That's actually a microcontroller-based platform, the STM32 ST Microelectronics. So let's step back and consider, what types of products make up the IoT. For starters, you have common things, common solutions to common problems. You have things that are already in the market that are being enhanced by adding connectivity. So then when those things get connectivity, all of a sudden we call them smart things. So now you have smart baby monitors or smart security cameras and garage door openers and things like that. But I want to say that, and some people question the usefulness of all these smart things. Well, I think that it's not really, the key is not to have individual things connected as just individual things. Really, the key is to allow them to interact with each other and apply dynamic logic to it. So if you take, for example, a connected car, if you just had real-time statistics on your car and your oil needs changing or your tire's slow or something like that, real-time statistics on your car is not that interesting. It's useful, but not everyone has to have it. Now, what's game-changing is when you have connected cars that actually talk to each other and figure out ways to make traffic jams become non-existent because they can deal with each other in more interactive ways, and they can make the traffic roadways safer than human drivers can. So the diversity of things and how they interrelate with each other is really what's going to be fun to watch, and also what's going to be helpful in tackling global problems. As you can see, the tomorrow of the Internet of Things is really that diversity of things that you bring together, and those problems can then be tackled on a regional or cultural basis. So just to emphasize that aspect one more time, solving niche problems I think is interesting. Sometimes common products can be customized by just adding logic and how things interact, but applying machine learning can go even further and make for more efficient outcomes. So a couple of these examples that I like to point out, students, I happen to know a story of some freshman computer science students, because in a suite of 8 students, and they wanted to allow the other kids from the university to get in and out of their suite without having to get out of their rooms to allow the other students in. So they took the knock lock example from the Arduino starter kit, and they optimized it, and they had the output go to a server motor connected to a full water bottle that was inside the door that would then drop onto the door handle to allow it in, because it was a key card entry and the other kids didn't have key cards that actually worked. So they created sort of a mechatronic means for making that work, which is kind of fun. Other things, backpack protection, laundry done, I'm going to show that. I even thought of something as I was preparing this talk, is like, imagine your parents may have a security system and they go in and out of the house and they set and they unset the security system and so forth. If you just tracked simple habits of that security system, you would know if something, like if they never turn it on or off during an entire day, you might be alerted to something's wrong. So that's another just example of something that came to mind as I was putting it together. So although there are many problems you can characterize as being generic, I think the solutions are not in the one-size-fits-all sector. You can optimize them and with interesting algorithms. And the holy grail of IoT and putting all this together, I think, requires inventors everywhere, inventors who understand their local problems. And so these inventors all over the country, all over the world, need open access to tools and technologies to allow them to put them together. And it's more, in my opinion, akin to the sharing that occurs in an academic environment. So they can put all this together. And speaking of academics, I wanted to show you a quick example here from product design class, a mechanical engineering product design class from last spring at Stanford. And there were 4 students that created this smartphone app. And the smartphone app on an Android phone was connected over Wi-Fi network in the dorm to an Arduino-based device that was sitting on top of the washers and dryers. The phone was NFC paired to communicate with a particular machine, and there was a little accelerometer inside connected to the Arduino core, and that device identified lack of movement from the washer and dryer. So when the cycle was done, it then alerted the student who had paired with that machine, and the student could even respond on the app saying that, there's little "I'm on my way," so that, other students would know that the dryers or washer is soon going to be open for their use. So you might, and then they created a little video as part of their presentation. So you might see this slide, which I just clipped some stuff out of their final presentation, and you might think it was a business plan being presented to some investors on Sand Hill Road. Well, instead it was being presented to the class. But if you think about it, they had minimal equipment costs. They retrofitted, existing washers and dryers. They had a plan that you could actually imagine starting a business on based on not investors on Sand Hill Road, but actually Kickstarter or Indiegogo, something like that. So, plus not all universities are as close to Sand Hill Road as Stanford. But if you take away the investor's expectation of needing that 10 times return on the Internet of Things idea, and if you imagine a lot of new IoT businesses, I think they could become profitable quickly, just on their own with like minimal investment. And I think that the IoT product companies, because they don't have to be giants, because they're solving problems that are smaller markets or niche markets, they can actually build stuff and serve those markets and be profitable. And you basically have a distributed amount of entrepreneurs in the world solving problems that don't have to have global sales. And so now you wonder why, how is it that 4 young entrepreneurs from Stanford can so easily create an IoT product? And I'd say partly it's because you've got the openness and the open access to the software that runs on the Arduino. You have the open access to the hardware designs. They're low cost. They don't need, this is key, they don't need to sign legal agreements, no NDAs, no big hefty licensing fees, all those things. They probably also went to the internet, went online, and started learning from other examples that were similar to the project they had in mind, and they copy these ideas and they put them together, and they actually solve that new problem. So I think definitely the IoT industry benefits a lot, specifically from collaboration around, I'd say, 2 major projects. The Linux operating system, which is a huge open source success story for microprocessors, and then the Arduino ecosystem, which is very successful on the side of microcontrollers. You put those 2 things together, and you have the microcontrollers interacting with the physical world. You get the microprocessors that are doing higher level applications and connecting back to the internet. And it's a great ecosystem we have right now for the success of the IoT industry. And I wanted to mention a couple more things about Linux itself. I don't know how much you've been involved in or understand Linux kernel development, but I think it's fascinating. Linux is arguably, one of the most important open source software. It's the largest and arguably one of the most important open source software projects in the world. And the development processes have been, and tools have continued to improve over time. This diagram on the left shows that how you can have literally thousands of developers that are part of what I'd call a trusted pyramid scheme of getting all of these code contributions reviewed and controlled by subsystem maintainers, who then support and push things to the next level, and ultimately you have this trusted pyramid of the software that all comes in, to the same source tree. And you probably, I don't know if you can see the parameters on that thing on the lower right, but the diagram shows that these contributions have accumulated now into over 15 million lines of source code in the single source tree. And so the result of Linux kernel, you can see up there, has definitely been a great boost for industry, for information technology industry. Now, on the side of open hardware, Open hardware has been very important to Internet of Things because you can take something, you start with a design that already exists, you take that design, and engineers can then prototype changes to that design, work their way toward a more cost-optimized solution, and with that cost-optimized solution, they can take it to market. And even Karen Schultz here is from Gumsticks. We've been talking to them, and they have the idea if you take the little industrial module off of this Arduino Yun industrial that I'm showing here, the little module is pre-certified from a Wi-Fi, from a regulatory standpoint, so you don't have to go through any of that nightmare. It's called land grid array, and there's manufacturing techniques that you can then build your own product design, slap that little module down, you have all the connectivity, you have the embedded Linux, everything ready to go, and that could be done in as little as 3 weeks' time. So I think that's pretty exciting for the hardware side of things. And there's just tons of sharing going on in hardware. There's other online tools you can use to design stuff. Now, we'll get on to a little bit more of the fun side of the talk. I'm going to show a few examples. First, I can just say that clearly IoT has taken advantage of open technology. And these examples show where you've taken a basic Arduino board and they created Vinduino. Vinduino is basically a soil and moisture monitoring and also irrigation system for vineyards. And in a lot of the cases, to make the Arduino things, Internet of Things, is just add connectivity. In the Vinduino example, you could either use Wi-Fi or in some cases they use LoRa long-range wireless radios to connect back to gather that data and manage it remotely. And there's numerous mechatronics and robotics things. So like this X-Carve picture there in the little black box with the red dot, that is actually just an actual Arduino inside that board, just a commercial off-the-shelf one. They didn't even optimize it or make their own or anything. And that's driving the mechatronics of the X-Carve machine. They're very popular also for 3D printers, what's called pick-and-place machines, and the CNC machines that do all sorts of industrial development of products. I saw recently, just doing some research, there's some really cool applications for agriculture that will actually harvest your fruits and vegetables without harming them because they have soft rubber hands and so forth. And there's like smart vending machines and all sorts of fulfillment robotics now for big companies like Amazon. Rather than have people going through and stocking the shelves, now they just have arms that go and reach out, package things up. It's a pretty cool time for Internet of Things advances. And so now going from the X-Carve machine where they didn't really modify the Arduino, I want to show you. And I forgot the examples. I actually have a few of these containers that I grabbed from this company. Here's a local startup. On the top of this picture here, each of their little black boxes actually has an Arduino that's doing a specific part of the mechatronics of this kiosk, which is really kind of like a vending machine. And what they're doing is they're vendoring fresh water. So there's water you just plug into the machine. You can add flavors. You can add some caffeine or not if you need a boost. And then it opens up the dispenser and spits out the water. The cool, interesting thing about this is it's 100% compostable container, so it's not actually contributing to the plastics of the world. It's all compostable. And then if you think about it, there's no water transportation costs. So the interesting thing about this is these are not even software engineers, they're mechanical engineers. They took Arduino. They're even using the standard Arduino IDE software. And rather than make things complex, they just added more Arduinos and kept it simple and something that they could imagine building. They also, you don't see on the far right, there's a Raspberry Pi, which is another very popular platform for open source technology. And the Raspberry Pi is the higher level applications because it runs Linux, and it's also their connection to the cloud. So they know when the water bottle empty supplies running low, or the flavors are running low, they then go send it out to be filled up again. Here's another industry example, and this one is instead more of an environmental it's another environmental efficiency thing, where this company, Enertrack, has sensors in the propane tanks that, tell if the tank is, it's fuel gauge basically, but then they communicate it over LoRa, long range, and you could use other communications. And so the delivery trucks, rather than having these routes that they go to every single tank and fill them up or not knowing how much is in there, they can actually now efficiently only send the trucks out to service those tanks that are low enough that they need to be filled all the way up again. So it's a great cost savings for that business. And again, this is just the tip of the iceberg. There's, I think, efficiency savings everywhere if you're able to monitor and manage that data, and even take actions remotely without having to actually physically be in these places. That's really one of the cool things about the Internet of Things. Of course, I had to add a few inspirational examples. Tanai happens to be sitting in the front row. She was working with a company called Backyard Brains, and this just shows how you can study neural stimulation, and one person's stimulation is affecting the other person. As ad hoc as it seems, it's actually really encouraging to see that you can do this type of neural research at such a low cost. There's just Arduino inside and a bunch of wires and cables and stickers and stuff. So they also have things that can be worked with animals, and there's a kit you can buy to study the neural network's functions on cockroaches, which Tanai gave a crack at. The robotic drums and the pancake thing were actually high school students that were showing these off at the New York Maker Faire. And so the drums are being played. There's a MIDI feed of whatever song or whatever they wanted to have the drums for, and then the drums were actually just playing these great songs, and the kids were having a blast with it. The pancake bot, if you want to call it, the pancake maker was actually, they hooked up spirograph designs into the Arduino software, and had a little baby bottle full of pancake batter, and then they just essentially dropped the batter onto the fry pan, and they were making pancakes with funky designs. So all of these things are driven by just a low-cost piece of hardware. The Arduino Uno, these are all the most basic 8-bit microcontroller examples. Now, here's just a few more because they're so fun. The image on the lower left was actually just a screenshot from a TED Talk that I highly encourage you to watch. It's a TED Talk of a 14-year-old kid who you can't really see in the picture, but one of his friends at a summer camp was struck by lightning, was drastically paralyzed, can't talk. And so the 14-year-old built this device out of an Arduino that's essentially a yes and no device. And they put things on either side of the head where the kid is, and they could ask questions. And this is the first time they tested it, and they were asking him questions about one of his favorite baseball teams, the Cleveland Indians. And the kid was answering the questions, and the first time he had communicated in months since his injury, and he was just overjoyed at being able to communicate with the real world again. And it was just a fascinating TED Talk. Then the wine bottle is actually a project here at PARC where they have entertainment streaming audio in the offices, and one guy made a little Arduino, stuck it in a wine bottle, and had it wirelessly connected back, and when you'd hear the music in the kitchen or something like that and you liked it, you just tapped the wine bottle and the LEDs would flash blue, and it would notch a like for that song that whatever was playing. So they had some positive feedback of the songs. Then the pumpkin here was actually one of the Arduino engineers this Halloween. I wish I could have embedded the video, but this pumpkin sings that he recorded lyrics, and he had 4 different facial expressions of the face that he cued to the lyrics, and it made it sing along with the songs. And then he actually had a sensor that would detect when a kid was walking up, and then this pumpkin would come alive and start singing like the theme to Ghostbusters in this case. So it's pretty cute. And then Tanaya got together with one of our engineers and first showed this dress off at New York Maker Faire. Here we're showing it again at Rome Maker Faire. This is the same one, the lamp demo I showed earlier, but basically this is a microcontroller-based touchscreen, and they created a simple user interface of multiple colors, and then you could just select the colors of the LED strands in real time and change the colors, which when Tanaya was at New York Maker Faire, the kids just loved it. You'd hand them off the thing, and they'd change all the colors, and there's a cute video of her where the girl's just going crazy tapping it. All right, so lots of my fun examples here. Let's see. So on Monday of this week, I actually had a chat with Hernando Barragan, who, by the way, is the real inventor, the guy behind the Arduino wiring framework. He was a student doing his master's thesis at the time in a design institute in Italy. And I asked him, I said, what do you find, I asked him what he thought was the most important thing regarding Arduino's use and being able to grow the Internet of Things. And what he explained essentially is that non-engineers, prior to Arduino, non-engineers really didn't have much of a chance of understanding or using microcontrollers. They were just way hard to use. And even myself, I was an electrical engineering undergrad, and I don't think I used microcontrollers after my labs in college until Arduino again, honestly. So, and now they've made me back to playing with electronics again. Makes it a lot easier. So. Recall what I mentioned earlier, we need inventors everywhere, right? So you don't even have to be an engineer, or you can be an engineer. You can be an inspired person that wants to somehow tackle engaging the digital world with the physical world and take data or actuate things. It really allows people to embrace their passion and engage with the types of things they enjoy and they like, and blend the physical world, the digital world, become one. So I think that was an interesting insight from him, that basically Internet of Things, what would that have meant if you didn't have a way to control and communicate with the things? Now, basically, lastly, I wanted to summarize the talk here, that what I see happening is really, as you can all see, it's a global opportunity. It's not something reserved for the 1% or the few big companies. And with open technology, you can have different cultures, tackle all the problems that are really most important to them. Could be climate, related, natural resources, economic conditions vary across the planet. And last summer, we met 2 young gals who were visiting for a program in the US called the Tech Women's Program. One was from Tunisia and the other was from Algeria, and they came here to get some mentoring in technology companies in the Bay Area. We talked to them, and both had used Arduino before in their own countries and loved it. And both wanted to remain in their countries, to grow where they grew up, and they wanted to help their own people and create their own growth in those economies. So I think it's important, that problem they have identified themselves is you get this brain drain problem where economically depressed nations, the smart kids don't have an economic viable place to work after they become educated, then they leave the country and go elsewhere. So, and they identified that as a problem. And most kids don't want to leave the place where they have family and friends and where they grew up. So I think the Internet of Things gives us a chance to tackle your own problems, your own diversity of your culture, those unique opportunities. You can stay and work anywhere. you can get funded, micro loans, crowdfunding, and Kickstarter, and Indiegogo can help you seed those projects. We can reemploy the heartland of America and really help, I think, to close the gap between the haves and the have-nots. So I just want to thank PARC for hosting me here at the forum, and I want to thank you all in the audience for coming, and I hope that you're all open to make the world a better place. And I'll leave the slide up for my question and answers and tell you that we do have a few We Love Open Source t-shirts here that we can give away. And
Not have to ask a question. Just get a free t-shirt.
And Tanaya Hurst is my other Arduino counterpart here in the Bay Area, and these pictures are actually her at the Girl Scouts at NASA Ames a couple weekends ago, inspiring the girls and showing them how to build LEDs. Yeah.
Model for companies to make money. I mean, obviously, it's great for hobbyists. It's great for spreading the word about IoT ecosystem. But where is the money coming from, and who's making money in IoT space today?
So that's a great question. The money is when you don't see it. When you don't see the money coming from. So there are big company examples, like some of the big problems, like Nest, for example, connected thermostats. You see big money there, but where you don't see the money, the small problems that are being solved. But what I'm seeing is there are small product design companies that are actually seeding in industry a medical problem, a security problem, and microcontrollers that are being used in industrial automation. So you don't actually, it's not very visible because, as I said earlier, the problems are so diverse that the problem solving is smaller and niche, and you have literally individual developers or small companies of 2 or 3 engineers making plenty of money in their own right. And there's like add-ons for car hacking, there's add-ons for all sorts of things that are going on. So there is money being made, and in fact the ecosystem around Arduino is much huger than Arduino's profits itself. We estimate it's probably 10 to 100 times bigger outside of our own company where money's being made, quite a bit of money. Well, the business side is kind of hard to dig out. We do show tons of examples of tutorials of things that are shared that are just fun things. That's why I have a lot of fun examples. Your business ideas, yeah, they're not sharing exactly what all they're solving, but people are definitely making money. Sorry.
Yeah, I'm a big fan of open source, but open source doesn't equate to interoperability. And I'm saying this in particular because the old Internet of Things right now has lots of different groups all saying we're going to be open source. You know, the All Seen Alliance, the Open Interconnect Consortium, et cetera, et cetera. So there's kind of a war going on between all these incompatible open source solutions for communications. My question really is Arduino. Does Arduino have a position on one of those multiple solutions, or where is that headed, do you think?
So no, we don't. So Arduino is most famous for what's called the API, the wiring framework that lets you easily control the microcontrollers. What communicates wirelessly, or the connectivity protocols, is where it's all over the map. And even this morning I saw yet another proposal for one of the other foundations. I'm a chair of a group in the Purple Foundation, and there was a proposal for NuNet, GNUNet, which is a peer-to-peer protocol that said then they'll build modules that would connect up to IoTivity and these other protocols. So there's definitely not been the consolidation that you might expect, and so what you need is at least the Linux blocks in your equation are going to be translators for now. Think of them speaking French and German and English and Norwegian, and they're going to be doing a lot of translation until you get a little more de facto standards or more common. I mean, there are some common ones coming out, MQTT, and CoAP, and now I mean, there's a lot of them. It's not clear to us who's winning, and we just want to let them all, you know, be used, and we'll see what consolidation happens after that. I'll take the guy with the mic, and then we can keep passing.
I noticed you didn't mention anything about security. Just a couple of weeks ago, the entire internet was
Yeah.
brought down by baby monitors and DVRs because these devices are spewing out packets without any control whatsoever. And I just read last week that the Philips Hue light bulbs were hacked so that one can get into the Zigbee network. So these things are all spewing packets on the internet and could eventually just bring everything down because there doesn't seem to be any way of protecting the internet from these millions of different devices. So what's happening there?
Well, that is a very big problem. And I've been talking to security consultants recently, and they really say we have to bring security into Arduino from the ground up because Arduino is so focused on education and prototyping, you kind of ignore the security stuff. Right now, the classic IDE doesn't have any security in it. That has to change. So we are talking actively to figure out what sort of security solutions are there. And on the commercial side, like some of our partners over here that run the minute.apache.org project, they've already built in security from the get-go, and they are a commercially supported, 32-bit microcontroller operating system. So they are targeting those deployments of millions of devices, and they had security in mind from the get-go. Let's hope that we can recover from all the stuff that already went out so far and doesn't have strong security. The other thing I'm seeing is on the Linux side, embedded OpenWRT as an operating system, they're starting to tackle the security problem as well. I think there's a lot of awareness to it. And then there's also, just at the silicon level, they're looking at, there's more ways to have hardware security checking and key management and things. And so I can't say it's in today's Arduino, but I definitely, when I mentioned the Arduino Foundation for 2017, that's got to be one of our areas to tackle, is making sure there's a security foundation so that when you bring these, you go from prototype to production. Even with your prototype, you should already have security baked into it, and then just be able to, make sure that you maintain that security as you bring a product to market.
Well, I give one comment. The biggest problem is if you have a Windows machine or a Mac, you are continuously getting updated as flaws are detected. None of these IoT devices are going to get updated. So even though if they go out with good security, the hackers will find a flaw, and there's no way that they can get updated, and they'll get taken over.
Well, that's going to change. That's the way it is today with the unconnected devices. They tend to have whatever they went out with, and even Wi-Fi routers today tend to be just sit there and have static firmware. But that is changing. Now you're moving towards smart routers and IoT hubs. They're going to be updated, every couple weeks. Just like look at Tesla now. I mean, spewed. I don't have one, unfortunately, but you're getting updates every couple weeks. That's what all the connected devices are going to start to have. And the microcontrollers, you're going to have the firmware that's going to be updated like that continuously. And that's where money is to be made by the companies who can actually maintain that firmware. Arduino's not that company. We're still focused on the prototyping and making it easy to use and educating people and getting you there. But then other companies will pick up the slack and deal with the constant upgrades of the software.
Do you have any examples of large-scale deployment of your hardware, or do companies that begin to grow end up designing customized, dedicated hardware?
Yeah, so like the X-Carve machine I mentioned, where they actually physically put one of our units right in the box, that's one model, but that's not the scale you'd want to use to millions. I've heard a sweet spot of maybe in the 10,000 range. Well, in the hundreds and thousands, you can probably get away with something off the shelf, but I would say up to about 10,000, you can get away with kind of put together modules of pieces that we have and some of the open designs. And then above that, you'd probably go to something completely cost optimized, where you're trying to squeak every penny out of it when you go above 10,000. But for example, I mentioned the gum sticks. They'll take modules that are off the shelf and you put it together like building blocks, and then you don't have to have huge upfront NRE costs. It's just a couple $1,000s, you get your product out in the market, and then you wait till you reach a bigger number before you do the super optimized solution.
Another question on behalf of my partner here.
Okay.
Arduino versus Raspberry Pi. I don't know if you talked about this earlier, we came late, but do you want to comment on that?
Yeah, so I get that question a lot. What's the difference between Arduino and Raspberry Pi? From the starting point, I think I had a slide mentioning Linux and Arduino. Linux targets something like the Raspberry Pi, where you're running a microprocessor. You have memory and processing and applications, and you have lots of resources. Even for the constrained devices, you still have a lot of capability. Arduino targets microcontrollers. Microcontrollers tend to be these real-time command and control things. They interact with the physical world. There's a rich set of GPIOs, general purpose inputs and outputs. You're actuating motors, or you're reading sensors, you're turning on and off things. And so they have, 20 to 50 to 60 of these inputs and outputs that can be controlled by the microcontroller, and there's very constrained memory and very constrained space, so you don't have, it's not like a full high-level operating system. So Arduino is tackling the tiny microcontroller market and giving you that interaction with the real world. They're commonly paired with OpenWRT or Raspberry Pi running some sort of Linux, because that's where your higher level applications and the connectivity, the internet and all the higher levels. So they're really at a different point, and they pair together really well. So if you just had a Raspberry Pi, you might have a few inputs and outputs, but very few, and you don't have real-time control for robotics or exact timing that you do with a microcontroller, where you have pulse width modulation and exact timing things you can do.
Great.
I'll take that guy and.
I really like the design of the water bottle example.
Okay.
But it seemed to me that what we've got is a network of Arduinos.
Yeah.
And I was thinking of his question about security. If we're going to do that kind of model that we've always done by pushing security out to devices like we do to laptops, don't we run the risk of breaking that kind of design every time we do a push? Because what if one of them doesn't like get the message and ends up not working?
Well,
Just a thought on the complexity
so
of the matter.
That's a trick of where when you know you need a highly reliable push, software updates, then you have basically a redundant thing. If the first firmware update doesn't take, you fall back to the one that was already there. Sometimes you don't have the space and the memory to make that happen. And but the security aspect is a little different from the upgrade aspect. I mean, the security is sort of independent. And if you have applications for like physical security where you're unlocking doors or giving access, then you want to target your even a stronger security with some of the microcontrollers have hardware security that you can include as part of your product. But the upgrade problem is, it is tricky to get that right, but there's a lot of solutions that the commercial vendors for those software packages are putting in place to make sure you don't brick things, because that is definitely a problem if you try to do a software upgrade and it fails. So you do a ton of testing before you deploy the software to the field. There was a question back there in the way back. Oh, sorry. I'll take this one on the microphone, and maybe you can get him a microphone. Yeah.
Hey, Kathy.
Yeah.
So Arduino is known for identifying and lowering all the major barriers to entry for microcontrollers and introducing people. I'm wondering what the major barriers that you guys have seen for introducing IoT, and how you guys are kind of solving that.
Okay, yeah, that's a good question. So I want to introduce Ben and Jeffrey. They're from Hologram, which is a SIM card data services for the cellular modems. We actually have a shield you can add to the Arduino that gives you data services so that you can use the cellular network to connect up your devices. And I should have included Ben's project from Halloween, because he developed, before I answer your question, he developed these unicorns for his 2 daughters, and inside the unicorn was a GPS tracker with the hologram SIM. And you know, they're old enough to go out on their own, but not old enough for mom and dad not to worry. So they were they were unicorn tracking girls going around trick-or-treating, which is a very clever idea. So yeah, so the barrier definitely is how you go from that prototype into a commercial product. And that's why we're trying to talk to encourage design companies and Gumsticks and these companies, design houses around Arduino who can take the open design. You've got information there that allows you to build the idea, but how do you take it to market? And so there's the hardware side of making things modular, so you can put things together and not have to recertify the regulatory pieces. And on the software side, we're engaging with more software partners, so you can use the advanced expert software, partnering with Runtime, for example, for the commercially deployed software. We can't do it all, but we can definitely advertise the ecosystem better than we are today, and that's one of the challenges for next year, is to put together this huge ecosystem of what it takes to go from your idea to products, IoT products. And then, question in the back? Educational aspect? Yeah.
Yeah, so I had the privilege of helping out a 9-year-old kid with a science project. So the project was rather simple. He wanted to measure the concussion on a baseball game.
Okay.
And then he was trying to use a QD module for that. So I had a real hard time explaining to him what is accelerometer, what is a gyroscope, and how do you measure that using an equation. To compare that with the Raspberry Pi example of Scratch or a Squeak. Do you have something? Are you guys trying for something similar?
I'm glad you asked that, because it's one of my new favorite things. Yeah, so there's the physical things of describing what an accelerometer or something is, but my new favorite software tool for kids for Arduino is Snap for Arduino. If you go to snapforarduino.org, fabulous. It's based on Blockly. It looks exactly like Scratch, but there's a tab on there that says Arduino, and you click on it. There's 2 buttons for like connect and disconnect your board. Really simple. And then then there's blocks like set digital pin 10 high or low. Read analog pin, you pick the pin, you know, and you put it together. I taught myself Snap for Arduino like at the IoT Expo floor, because we wanted to show it in conjunction with this QNAP product that could run Snap locally for schools. I think education is going to be turned on its head as soon as we get Snap for Arduino in the schools, because it makes programming so much more fun. You get to click the block and it just activates in real time. There's just a standard firmware on the Arduino, and so when I set that pin high, it just goes high right there. If I read the data, I just click on the block, I read the data. I took one of Tanaya's examples of a night light thing where you have a photocell that's looking at that gives you an analog input based on if it's covered or not, and then there's another LED that you turn on, and so you cover the photocell, the LED turns on, you open the photocell and it turns off. And I basically took that sketch, threw it into Snap for Arduino, and you can click on every block and you can see what's going on exactly as you're doing it. The other encouraging thing about Snap is Snap and Python are going to be replacing Java as the AP computer science curriculum for high school students. So high school classes can be doing real robotics, Internet of Things with Snap, and then Snap translates to, you can translate, transpile, they call it, the Blockly based or visual programming into an actual other language. If you translate it to JavaScript or Python or even the Arduino IDE. So education is a huge area of growth that we're definitely looking forward to.
So for the IoT, like I'm super interested in it, but I don't have strong programming skills. Do you guys have any programs like to help with that? Like in terms of like if I just want to Arduino which locks or unlocks a door, like is there some way for me to make a program easily for that?
Well, since you're in the Bay Area, you could come down and come to one of our Arduino meetups. But where most people get the ideas is just going online. There's like Instructables, Inventables, Maker.io, and there's just numerous websites where people share their projects, Hackster.io and Hackaday, and you find all these projects, like Ben's project on the unicorn is already posted on one of those sites. So you just pick up an example of something that's similar to what you want to do, and then we tweet or post these on, we pick a project I think once a week or once every 2 weeks, and we highlight a key project on our website, for example. So I would say start with the online sites, and then there's hackathons and workshops and meetups. You look for the area, and hopefully, we've had only one so far Arduino Developer Summit. We held it last June, and it was kind of an invite-only, 50 key partner developer, key stakeholders in the Arduino community. But our goal is to start making more Developer Day, Developer Summit type events once we have the increased funds for it, so that you'd be able to learn. And there's, regarding the Internet of Things, I think there's a lot of partners and big companies like Intel or silicon vendors that will fund some of these workshops too, where we can get our hardware into the workshops and programs. And I'm in discussions with various silicon vendors that want to show off their hardware, and so there should be more opportunities for education. And the programming, again, you can start with Snap for Arduino. Piece of cake. It's fun.
Great, we'll take one last question.
Bring up that brain drain slide.
The brain drain slide,
Yes.
sure. Whoops, right here.
Yeah, my question is, instead of looking at it globally, if you look at third world, say Africa or India,
Yeah.
those countries, a lot of people live in the villages, urban areas. So what application can you think of for those people instead of looking at only cities? where
Oh,
IoT
it
application, all
definitely
this revolution?
doesn't have to be cities. There are so many agricultural, water
Yeah,
quality,
exactly.
environmental, huge. I mean, that's specifically these two gals from Africa, Tunisia and Algeria. They wanted to solve their own local problems. There's lots of problems to be solved. Even poaching of animals. There's all sorts of sensors and things you can do. And this coming year, Arduino, we should have long-range communications coming, which will go kilometers with low power, low energy communications, and it's independent of the cellular network, even though you can set it up like a cellular network. So I think those are going to be huge for rural areas and long-range communications where you don't need to pay service providers. And there's a network called the Things Network, which is already an open community network around LoRa.
If I can comment on that,
Sure.
actually. We've all heard of Smarter Cities, and I've been
Smart
part of a
Cities, yeah.
Smarter Cities program as well as part of IBM. But there's a Smarter Village program, the pilot happening in December. Actually, it's gonna be inaugurated in India. You don't know, perhaps, as part of UC Berkeley, and the professor Simon is leading that delegation. IBM, Intel, Microsoft, all of these are putting together efforts to create a low-cost housing, cleaner water,
Yep.
sanitation, all using IoT sensors. And so I'm sure there's a lot more to come. We have more villages in the world
Yeah.
than cities, and it'll all benefit humanity.
And one of my favorite things is the humanitarian hackathons. There are these programs now where you have humanitarian hackathons where they bring some problems that are rural that I would have never known about, and they will, hack on them and then bring people together.
Looks like we have one last
question,
question.
sure.
It's not really a question, it's to complement his last question.
Yeah.
We are from a company that is really focused in this specific space that is livestock, especially in Latin America, Africa, and some other countries, also in US. And we also make hackathons for our platform to let makers around the world to build their own sensors to and their own business on top of our platform. So I would like just to suggest as an example of something for the third word. It's BOV control for bovine, BOV control.
Both control.
Yeah.
Again, thank you, everyone.
Great, thank you very much, Kathy. So just a quick reminder also, we have the next PARC Forum that's going to be on Thursday, December 15th. It's Dr. Catherine Isbister from UC Santa Cruz, and she is going to share some of her research regarding the interactive experiences and with designing the games and social and emotional connections. So she'll again be here on December 15th. Registration is open, so please come join us for that. Thank you very much.
Thank you.
So
Good.
much. Missed your first 10 minutes, but
No problem.